Hello. In this video, we will examine the basic concepts of the theory for the motion laws of kinematics for 11 ESP, the chapters 1.2 and 1.3, and we're going to see a few questions that are related to these objectives. Now, the basic topics that we need to remember is that the function of position can be described as x or r, and the velocity and the acceleration. The velocity is derivative of the position, and the acceleration is derivative of the velocity. And also, we need to remember the laws of kinematics from grade 10 for the motion with constant speed or motion with constant acceleration, the laws of freefall motion, and the fact that since the velocity is derivative of position, position will be antiderivative of velocity, and since acceleration is derivative of velocity, velocity will be antiderivative of acceleration. Now, let's remember a few things about motion in kinematics. Now, the change of position from the initial position to final position, we call it displacement. Now, the basic reason why we prefer to use displacement and not distance is because displacement can be positive or negative, and this gives us information about the direction of motion. So, in this case, the displacement is positive. If we had position initial and position final, then the displacement would be negative. Now, there is the concept of the average velocity, which is distance over time or displacement over time, and acceleration is the change of velocity, so acceleration is change of velocity with respect to time. Now, any motion has a function of position, of velocity, and acceleration. And we need to know that the velocity is the derivative of position, and the acceleration is derivative of velocity. And the reverse, that the change of position is antiderivative of velocity, and the change of velocity is antiderivative of acceleration. Now, one more thing that we need to know is that the meaning of derivative is the slope of the position versus time graph, or the derivative of velocity is the slope of the velocity versus time graph. So we can find the velocity and the acceleration from the slope of the position or the velocity graph. And the meaning of antiderivative is area under the graph. So the change of position is area of the velocity graph, and change of velocity is the area of the acceleration graph. So if we have a slope for the position versus time graph that is pointing upwards, then the velocity is positive, and a slope that is pointing downwards, then the velocity is negative. Now, for the velocity versus time graph, we can have constant velocity or negative constant velocity. So if we know for a fact that we have motion with constant velocity, the velocity will be staying the same, it will not be changing, and the acceleration will be zero if we have motion with constant velocity. And again, if we have motion with constant velocity, the slope of the position versus time graph will be constant. And for motion with constant acceleration, we are familiar with the laws of motion, but since we have motion with constant acceleration, it means that we'll have change of speed. So the speed versus time graph will be either speeding up or slowing down. Now, if we're speeding up, the slope of the graph is zero at the start and not zero at the end of the line. And if we're slowing down, the slope of the graph is not zero at the start and zero at the end of the line. And if the acceleration is constant, then the line will be completely horizontal. Now, for any graph, we need to be familiar that for the position versus time graph, the slope is velocity. For the velocity versus time graph, the slope is acceleration and the area is change of position. And for the acceleration versus time graph, the area is change of velocity. Now, this is going to be a little bit long. We will have quite a few questions because this is quite a long topic. So get prepared and let's try to answer the following questions. I'll give you some time to read the question. If you want, you can pause. Now, what we know is that a toy is launched from a 20-meter high horizontal table, and just so we release the object from a high table, and just before we reach the ground, the toy has a speed of 32 meters per second, and we need to figure out what is the speed which the car was launched on. So actually, we don't know that the toy car was released. We throw it down. So this is an example of free fall motion. For free fall motion, we're using the three laws of motion. V final is equal V initial plus AT. It's just that we know that the acceleration is g and negative, so plus gt, but the value of the g will be 9.8 meters per second squared downwards. Or we can say that the change of the position, the delta y, is equal v initial t plus 1 over 2 at squared, but the acceleration is g and downwards, and the v final squared is equal to the v initial squared plus 2a delta x, or in this case delta y, but again the value of the g is negative. So in some cases, some students might prefer to write the laws as with the minus, and just know that the value of g is 9.8. Any of these two laws, any of these two ways will give the correct answer. Now, since the given is the final speed and the change of position delta y, and we need to find the initial speed, most likely we're going to work with rule number 3. So the v final squared is unknown, the v initial squared is 32, minus 2. Now for simplification reasons, I will use, instead of 9.8, I will use 10 in my calculations, multiplied by the height that it is 20. But we have to be a little bit careful here, because the toy car is launched from 20 meters above the ground and it reaches the ground. So actually the delta y is negative 20. So multiplied by negative 20. So the car is falling down and it has a negative displacement. So the v final squared is equal, now we have to go to the calculator, into 32 to the power of 2, minus and minus become plus, so plus 20 times 20 times 400, and then find the root of this answer, which is approximately 37.7. Sorry, the v final squared, the final value will be 37.7 meter per second. We can continue. We have an equation of position, and we need to find the acceleration of this object at time is equal to seconds. I can give you some time to think about it and pause, but we need to remember that we cannot find the acceleration directly. First, we need to find the velocity from the derivative of position, and when we have the value, the function of the velocity, we can find the acceleration from the derivative of velocity. So first we try to derive the expression 6t to the power of 3 minus 5t plus 1. So 6 times 3 times t to the power of 2 minus 5. So the velocity as a function of time is 18t squared minus 5. And now we will find the acceleration as a function of time by deriving this expression, 18t squared minus 5 derivative. So it is 18 times 2 times t plus 0. So it is acceleration as a function of time is 32t. And because, 36t. And because we are given a certain value for the time, we're going to replace that the acceleration when the time is 2, it is 36 times 2, so the result is 72 meter per second squared. We can continue with another example for kinematics, and and we are given an expression for velocity. And from this, we need to find the average velocity between 1 and 2 seconds. Now we need to remember that the average velocity is displacement over time. So first we need to find the displacement, and then we can find the average velocity. And we remember that the displacement is integral of the velocity dt from initial time to final time. Now we can use our calculator to open an integral from 1 second to 2 seconds, 6t squared plus 4t minus 3 dt. Now in the calculator we're going to use integral of x instead of t, but we're going to find the same answer. So it will be 6t x squared plus 4x minus 3, and the result is 17 meters. And now that we know the displacement delta x, we can say that the average velocity is displacement over the time. The time is from 1 second to 2 seconds. It is 1 second. So the answer is 17 meters per second. We can continue to the next question, which is about kinematics and motion with acceleration. You can pause to read the question. However, what we have is a motorcycle that accelerates from rest, so the initial velocity is 0, and it accelerates with 1 meter per second squared for 4 minutes. Now, 4 minutes means that the time is 4 times 60, it is 240 seconds. Then the motorcycle slows down to rest, and we need to find the average speed of the motorcycle from when it starts until he stops. So, since we need to find the average speed, we need to find the total distance divided by the total time. Now there is a problem, we don't know the first distance, but it is not so difficult to find it. Now, unfortunately, there are two motions. One motion when the motorcyclist is speeding up, and then another motion when the motorcyclist is slowing down. So we need to find two distances. In order to find the first distance, we can use the law delta x is equal v initial t plus 1 over 2 at squared. So the delta x is equal 0 plus 1 over 2 times 1 times 240 to the power of 2. Now this is 28,800 meters. This is the first distance. Then we need to try to apply the same law for the second distance, but we have a small problem. In order to find this, we need to know what is the speed at the start of the motion, and we know that the final speed is 0, and we know that the acceleration is 2 meters per second squared, but because he's slowing down, we will need to consider the acceleration negative. Now, the v initial of the second motion, in reality, it is the v final of the first motion. So we need to spend 1 minute to find the v final. V final is equal v initial plus at. The v final is, the v initial was 0, the acceleration was 1, and the time is 240. So it is 240 meters per second. And this v final, it becomes v initial of the second motion. So we know the v initial, we know the v final, and we know the acceleration. So maybe we can use the second law of motion to find the distance, but we don't know the time. So first we'll say v final is equal v initial plus at, because we need the time as well. The final velocity is 0, the initial velocity is 240, the acceleration is -2. So from this we find that the time is 120 seconds. This is the second time, and this is actually useful. And the delta x is equal v initial t plus 1/2 at squared. The v initial is 240, the time is 120 minus 1/2. The acceleration is 2. The reason why I put minus is because we're slowing down, multiplied by 120 to the power of 2. Just give me a minute for this calculation. This is 14,400 meters. So from this we can say that the total distance is 28,800 meters for the first part, plus 14,400 meters for the second part, divided by the total time, that it is 240 seconds for the first part, plus 120 seconds for the second part. So the final result is 120 meters per second. We continue to the next question, where we need to find the average acceleration of an object that it is moving between the time 2 and 3 seconds. And we remember that the average acceleration is change of velocity with respect to time. So we have v final minus v initial divided by the time. Now the time is clearly given, 2 seconds, but we need to find the initial velocity and the final velocity. And in order to find the velocity as a function of time, we need to derive the position. So the first derivative will be 2.3 times 3, so 6.9 t squared, minus 5 times 2, 10t, plus 6.5. And now that we have an expression for the velocity, we'll find the velocity when the time is 0. This is the v initial, so 0 minus 0 plus 6.5. And the velocity when the time is 2, this is the v final, so it is 6.9 times 2 to the power of 2 minus 10 times 2 plus 6.5. We need a calculator for this. If I'm not mistaken, this is 14.1 meters per second. And we can replace them on the expression for the average acceleration. 14.1 minus 6.5, and then divide by 2. So the result will be 3.8 meters per second. And this is acceleration, it should be meter per second squared. We can continue. Again, feel free to pause the questions in order to read them on your own pacing. What we have is a car that starts from rest and it accelerates with a constant acceleration for 4 seconds, and then it continues with a constant velocity. And we need to find what is the total distance that the car traveled. So we have two motions, one motion with acceleration, so there is a delta x for the first motion, and then another motion with constant velocity. The v is constant, and there will be a second distance. Now, in order to find the first distance, we can use the expression delta x is equal v initial t plus 1/2 at squared. The initial speed is 0 since we're starting from rest, so it is 1/2 times 1.2 times 4 to the power of 2, so 16 times 0.6, the first distance is 9.6 meters. However, the car reaches a speed that we call v final, and this v final will be the constant speed of the second motion. So somehow we need to find this v final, and we can say that the v final is equal v initial plus at. The v initial is 0 plus a, which is 1.2 multiplied by 4, so it is 4.8 meter per second. And again, this final speed of 4.8 meter per second, it is the speed of the second part of the motion, so it is 4.8 meter per second. And since we have motion with constant velocity, we are using that the velocity is displacement over time. The velocity is 4.8. The second displacement is unknown, and the time is 6 seconds. So the delta x2, it is equal 4.8 times 6. The result is 28.8 meters. So the total distance is 9.6 meters plus 28.8 meters, and the answer is 38.4 meters. We can continue with a motion graph, with the graph of the acceleration with respect to time. We know that the object starts with an initial velocity of 3 meters per second, and actually we see that, the velocity initial is 3 meters per second, and we need to find what is the final velocity. Now, this is a motion with variable acceleration, so we cannot use any of the laws that we know for motion with constant acceleration, because the acceleration is not constant. But we need to remember that from the acceleration versus time graph, the change of velocity is equal to the area under the graph. Now, we have two areas from 0 to 8 seconds. We have the first area that it is negative and the second area that it is positive. Now, the area 1 is half base height, the base is 3, and the height is 3, or since we have a negative area, I will consider it negative 3. So the first area is minus 4.5 meters per second. And in a similar way, the second area is again half base height, so half the base is 5, and the height is again 5, so it is 12.5. Now the total area is minus 4.5 plus 12.5, and the change of velocity is v final minus v initial. The v final is unknown, the v initial is 3, and the result is minus 4.5 plus 12.5, it is 8, so the v final is equal 11 meters per second. We can continue, and you can pause for 1 minute in order to read the question. We have a velocity versus time graph, and we need to find the displacement from 0 to 9 seconds. And we remember that from the velocity versus time graph, the displacement is equal to the total area under the graph. Now we have the area 1, the area 2, and the area 3. Now the area 1 is a triangle, so half times base times height, plus the area 2 is a rectangle, so length times width. The length is 3 and the width is also 3. Now the area 3 is a little bit difficult because we have a trapezoid, it's not a triangle. Now there are two options: either you will break the trapezoid into a triangle and then a rectangle, or you can take the law for a trapezoid, which is base, large base, which is 3, plus small base, that is 1, multiplied by the height, that it is 3, divided by 2. So we have 4.5 plus 9 plus 6, and the result is 19.5 meters. Now we have a value function for acceleration, and we need to find the velocity when the time, we need to find the equation for the linear velocity, not the value for the velocity, but the equation for the velocity, knowing that the initial velocity is 7. So we remember that the change of velocity is antiderivative of acceleration. So the velocity as a function of time minus the initial velocity, it is equal with the antiderivative of minus 9t squared plus 4t. So velocity as a function of time minus 7, it is equal minus 9t to the power of 3 over 3 plus 4t to the power of 2 over 2. So the velocity as a function of time, at the end it becomes minus 3t to the power of 3 plus 2 times t to the power of 2, and if we bring the negative 7 to the other side, plus 7, so the best answer is B. We have another question that is telling us that an object is released from rest. It travels a distance of 1 meter during the first second, and we need to find the distance for the second of the motion. Now we know that the v initial is 0, we know that the distance is 1, and we know that there is acceleration. And when we find this acceleration, probably we'll need to find the second distance from with a different initial velocity that will be the final velocity of the previous motion. So we have first to work on the first part of the motion in order to find the acceleration and the final velocity. Now probably we're going to use the second law in order to find the value for the acceleration. Delta x is equal v initial t plus 1 over 2 at squared. We know that the delta x is 1, we know that the initial velocity is 0, and we have 1 over 2 unknown acceleration, and the time is 1. So from this we find that the value for the acceleration is 2. And now that we know the acceleration, and we're going to use this for the second motion because it is the same motion, we can try to find the final velocity of the first part of the motion, v initial plus at. The v initial is 0, the a is 2 times 1, so the final velocity is 2 meters per second. So for the second part of the motion, this 2 meters per second becomes the initial speed. And now that we know the distance and the acceleration and the time is from 2 seconds to 1 second, so the time is 1 second again, we can say that the second distance is v initial t plus 1 over 2 at squared. The v initial is 2, the time is 1, the acceleration is 2, and again the time is 1, so it is 2 plus 1, the distance during the second is 3 meters. You can pause to read the question, but this is a question about a function of velocity, and we need a function of the acceleration, so we need to say that the acceleration is velocity derivative, so minus 5 times 2 times t plus 4, so the value is minus 10t plus 4. And we continue with another question for kinematics. An object starts from rest, so the v initial is 0, we have the acceleration, and we have a distance. However, we need to find what is the speed at a distance of 5 meters. Now we're going to try to take the third law of the motion to see if we can answer directly, but I'm not sure about this. V final squared is equal to v initial squared plus 2a delta x. The v final squared is unknown, the v initial we said that it is 0, 2 times 6 times the distance of 5 meters. Okay, so the v final squared, it is equal 60, and the v final is root of 60, so it is 7.7 meters per second. So either I'm not reading the question correctly, or and accelerates uniformly to 6 meters per second. Sorry guys, I made a big mistake. I didn't read the question correctly. This is a final speed, not an acceleration. So I don't know exactly how much will be the speed at a distance of 5 meters, but probably it's going to be less than 6 meters per second, so the answer will be one of these three. But we're going to take the same law in order to find the acceleration. So v final squared is equal to v initial squared plus 2a delta x. So 6 squared equals 0 plus 2a times 10. So 36 is equal to 20a. So the acceleration is 1.8 meter per second. And now that we know the acceleration, we're going to take the same law, but for a new distance. So v final squared is equal to v initial squared plus 2a delta x. The v final squared is unknown. The initial speed, we said that it is 0. 2 times 1.8 times the distance, that it is 5. So the v final squared is a root of 18, and if I'm not mistaken, the root of 18 is 4.2. Yes, so the v final is 4.2. I apologize for the construction noises that you hear. Unfortunately, this is beyond my control. We can continue. We have an object that we know that it moves with an acceleration, a constant acceleration, and an initial velocity, and we need to find the time to travel a distance. Most likely we're going to use rule number 2. We know the distance, we know the initial velocity, we don't know the time. Half of 4.6 is 2.3 t squared. Unfortunately, this is a quadratic equation, and in order to solve this, we're going to bring every time to the right side of the equation. So 2.3 t squared plus 12t minus 50 is equal to 0. And we need to use our calculator for the quadratic equation mode. The a is 2.3, the b is 12, and the c is negative 50. So we're going to find two values, probably one positive and one negative. So the time should be 2.7 seconds, or the time should be minus 7 seconds. So we're going to use the positive value. Now we have a graph of velocity with respect to time, and the question is, at what point the acceleration is 0? Now, we remember that the acceleration is the slope of the velocity versus time graph, so the point where the slope is 0 is point C. Now, the meaning of slope is the inclination, so at any point A, B, or D and E, there is an inclination, and we can see it clearly. The point where the tangent to the graph is horizontal is at C, so at point C, the inclination, the slope, is 0. We have an expression for the position x, and we need to find the value of the acceleration. I think we solved something similar to this. First, we need to say that the velocity is derivative of position, so minus 3 times 4, 12 t2, plus 10t plus 3, and then we will find the expression for the acceleration, which is the derivative of the velocity, so minus 24t plus 10. And we need to substitute the value of 2 seconds, so minus 24 times 2, 48 plus 10, so it is minus 38 meter per second squared. We continue to a question about the motion with constant acceleration, and we need to find the final speed, so v final is equal to v initial plus at. The final speed is unknown, the initial speed is 0 because we're starting from rest. The acceleration is 3 and the time is 6, so it is 18 meters per second. And in order to find the distance, most likely we're going to use rule number 2, v initial times t plus 1 over 2 at squared. The v initial again it is 0 because we're starting from rest, so 1 over 2 times 3 times 6 squared. 36 multiplied by 3 it is 108, divided by 2 is 54 meters. Now we have a graph of acceleration, and the question is, what is the final velocity of the person after 12 seconds, not the final velocity, but what is the velocity at 12 seconds, knowing that the initial speed is 5 meters per second. And we need to remember that from the acceleration versus time graph, the area of the graph is the change of velocity. Now the change of velocity is v final minus v initial, but the v initial is 5. And the area of the graph is, we need to find the area until the 12 seconds. So for the first 10 seconds we have the area 1, and later we have the area 0. So the first area is length times width, 10 times 2, so 20. And this means that the v final will be 20 plus 5, 25 meters per second. If we're going to stop at 12 seconds. In a similar way, we need to find the velocity at time equals 6 seconds. And again, we are given an acceleration versus time graph, but now we're going to use the whole area of the graph. And again, we have two areas. The area 1, that is length times width, so 2 times 2, it is 4. And an area 2, that is length times width, so 2 times negative 2, so it is equal to minus 4. So again, the change of velocity is the total area, so 4 minus 4. The change of velocity is v final minus v initial, but we start from rest, so the v final has to be 0. We go to a graph question, and we need to figure out what is true about the velocity and the acceleration on point A. Now, this is a position versus time graph. This is the first thing that we need to check, what kind of graph we have, and we remember that the slope of the graph, the slope of the position versus time graph, is the velocity. So, since the inclination is upwards, the velocity has to be positive. However, the acceleration depends on if the object is speeding up or slowing down. If the object is speeding up, then the acceleration is has the same direction like the velocity. If the object is slowing down, then the acceleration is opposite to the velocity. In this case, since the velocity is positive, if we know that we speed up, the acceleration will be positive. If we know that we're slowing down, the acceleration will be negative. And in order to figure out what happens if the object is speeding up or slowing down, we need to check what is happening to the slope of the graph. And we see that at the start of the graph we have a great slope, and at the end of the line near A, we have a smaller slope. So this means that I have a great speed and a small speed, or a v initial that has a value and a v final that has a value of 0. So the object is slowing down, and this means that the acceleration has to be negative. So the best combination is that the velocity is positive and the acceleration is negative. And this is our answer. We continue with another graph question. Again, this is a position versus time graph. This is the first thing that we need to check, and then check the question. What is true about the motion of the object? I will not really read the options, but we need to see what happens to the velocity. So the slope of the graph at the start is 0. This means that the initial velocity is 0, and later the slope is not 0, so the final velocity will have a value that it is not 0. So let's say that the final velocity has a value of 10. Since the initial velocity is 0 and the final velocity is 10, it means that the object for sure is speeding up. So the only possibility is C and D. And one more thing, since the object is moving, since the inclination is upwards, since the slope, the overall slope is upwards, okay, at the beginning was 0, but at every other point the slope is positive. This means that the velocity is positive. So it speeds up in the positive direction. Again, at the start the slope is 0, and later the slope is not 0. That's how we realize that the object speeds up, and since the slope is positive, the velocity is always positive, so it speeds up in the positive direction. Now this kind of question should not be difficult now, because we have an equation of motion, and from this we can find acceleration and initial position. Now the acceleration is a little bit easier, so I'm going to start from this. It's derivative of velocity, so minus 6t plus 4, and if we replace the value of 2 seconds, minus 12 plus 4, so minus 8 meters per second squared. Now in order to find the position, we have to say that the change of position is integral of the velocity, so integral of minus 3t squared plus 4t from time 0 to time 2. The change of position is x final minus x initial, but the x initial is 0, so we need to open an integral from 0 to 2 of minus 3 x squared plus 4x, and the value is 0, so the x final will be 0. We can continue to one more question about motion with constant acceleration. And we know the initial speed, that it is 12. We know that the car is slowing down. We know that the distance is 80 meters and the time is 8 seconds. And from this we need to find the final speed and the acceleration. I believe that first we're going to find the acceleration from the law of the delta x. Delta x is equal to v initial t plus 1 over 2 at squared. We'll find the acceleration negative, but the question is about the magnitude of the acceleration. So the v initial is 12, the time is 8, 1 over 2 a times 8 squared. Now 80 minus 12 times 8. So if we take this to the other side, the result is negative 16. This is equal to 64 divided by 2, 32a. So the acceleration is negative 0.5 meters per second squared. And now that we know the acceleration, we can find the final speed. V final is equal to V initial plus at. The V initial is 12 minus 0.5 times 8. So 12 minus 4, the result is 8 meters per second. Then we have a car that is moving on a road. Then the car decides to hit the brakes and slow down with an acceleration that we know, a time that it is given and the final speed that it is given, and we need to find what is the distance that it is traveled. Now we have a small issue here. If we try to use the second law, we don't know the v initial. I think that we know the acceleration and the time, but we don't know the v initial. So maybe we need to use the third law. We know the v final, we don't know the v initial, and I think still we cannot really use that law to a times delta x, because we don't know the v initial and we don't know the distance. So maybe first we need to use the first law, v final is equal v initial plus at. We know the v final, we know the acceleration, we know the time. So first we're going to use the first law. So 33.3 is equal v initial minus 2 times 4. So if we take the 2 times 4, which is 8, we're going to find that the v initial is 41.3 meters per second. And now that we know this v initial, we can find this value for the distance, which is 41.3 times the time plus 1 over 2 times 80 squared. I wrote the law wrong, or actually the iPad didn't catch my writing. 80 squared. The acceleration, we said that it is -2, and the time it is 4 to the power of 2. Now we need a calculator probably. 41.3 times 4 minus 16. So the result is 149 meters. Now we're going to select the closest value, and we can check our calculations one more time in case we made a mistake. The driver slams the brakes, the car slows down with an acceleration that we know, a time that we know, and the speed is known. So we know speed, acceleration and time, unless I made a mistake in this calculation, for 33. I said 43.3 for some reason, but the actual value is 33. I don't know why I did this. So if we change our calculations a little bit, I believe we're going to find 148 meters. And we're going to continue with 3 graphs questions, and then we're going to take a break. Now, we have 5 position versus time graphs, and we need to understand which one of these graphs shows a speed that it is increasing. And since it's a position versus time graph, no way the answer is B, because we have straight line. Straight line on the position graph means constant speed, so no way B and no way E. Straight line of the position versus time graph means that the speed is constant. And in order to understand what's happening to the speed, we need to figure out what is happening to the slope. And on the first graph, the slope at the start is 0, and later it is not 0. So actually the answer is A, because the speed increases. In the other 2 graphs, we have a non-zero slope at the start and a 0 slope at the end. A non-zero slope at the start and a 0 inclination at the end. So the speed decreases. Now we have again a velocity versus time graph, and we need to find a few information like what is the acceleration, what is the displacement, and what is the total distance. Now the acceleration on the position versus time graph is equal to the slope. So we'll go at 8 seconds, somewhere here, and we're going to try to find the slope. Now the slope is rise over run. Since this is a straight line, I can take the constant slope of this line, and the rise is from -12 to positive 18. So it is 18 minus -12, and the run is from 4 seconds to 9 seconds. So 9 minus 4, so the result is 30 over 5. The acceleration is 6 meters per second squared. Again, we don't have to go exactly to 8 seconds. We can take the slope of the whole straight line. Since it is a straight line, the slope is constant. We can select any 2 points on this line. I selected the start and the finish. Now we need to find the displacement between 13 seconds, 13 seconds is here if I'm not mistaken, and 18 seconds is there. So we need to find the displacement, and we remember that on the velocity versus time graph, the displacement is equal to the area under the graph. So we're going to find only that area. It is half base height, and if we check carefully, the length, the base is from 13 to 18, so it is 5, and the height is 18. So the value is 45 meters. And since we need to find the total distance, unfortunately, we have to find a few areas. This will take a little bit of time, I believe. So we have the last area that we don't need to calculate. We know that it is 45. We'll need another 2 areas and another 2 areas. So the area 1, the area 2, the area 3, and the area 4. Let's start with the area 1, that it is length times width, so it is 4 times 12, or actually 4 times negative 12, so minus 48. The area 2, that it is a small triangle with base 2 and a height negative 12. The area 3, that it is a small triangle with a base from 6 to 9, so it is 3 times 18, and I made a mistake, I wrote 1 over 3, I should have written 1 over 2 base times height, so it is 27. The area 4, that is rectangle from 9 to 13, so it is 4 times 18, so it is 72, and the fifth area we have already calculated that it is 45, so if we add them all up, minus 48, minus 12, plus 27, plus 72, plus 45, the result is 84 meters. And I made a mistake because the question is not about finding the displacement, the question is about finding the distance. So we will ignore the signs, so we have to actually add the absolute values of all of these questions. So 48 plus 12 plus 72 plus 45, the result is 177, the closest value is 180 meters. We could check our calculations one more time, but I believe that the answer is correct. And one last question before we take a break. We have a graph of position versus time, and we need to find what is the speed, what is happening to the speed, and what's the direction of motion. The easy part is the direction of motion, that since the inclination of the graph is positive, the direction of the motion is positive. One more way to understand the direction of the motion is just to put some random values, for example minus 20 and minus 10 and 0, or minus 1. So basically the object moves from the position of minus 20 to the position of minus 10 and to the position of minus 1, so the object moves to the right. Now, regarding the speed, a little bit carefully, the speed is the slope of the graph, so we have a slope at the start and later the slope is 0. So the speed is decreasing, so the combination that gives us the correct answer is that the speed is decreasing and the direction of motion is positive. Now we're going to take a break from here. Feel free to make your comments or ask a question, and we will continue on the same topic in a second video. Thank you for watching.